Hello everyone. In this fourth video, today we'll delve a little deeper into the world of electrical transformer maintenance. If you've ever wondered how our electrical grid works, this video will summarize it for you with easy-to-understand examples. But can you tell me what transformers are for?
They are the silent heroes who ensure that electricity efficiently reaches our homes and industries.
Exactly. To understand their importance, let's imagine a heart pumping energy through the veins of a city. It sounds poetic, but that is the vital role of transformers.
And to operate efficiently, transformers need constant maintenance. Today we'll talk about the technologies that are revolutionizing this task, won't we?
First, let's talk about smart monitoring. Imagine small sensors acting as watchmen inside and outside the transformer.
These sensors measure parameters such as temperature, humidity, vibrations, and dissolved gases in real time. It is like having a personal doctor for each transformer.
This allows us to detect problems before they become serious failures. But what role does artificial intelligence play?
A crucial role. For many of these things, in the analog era, the control units or sensors were in charge of doing that job. But this equipment was dumb and it was not possible to monitor them, see historical data, analyze problems, etc. With the new equipment and sensors, you can analyze all this data with artificial intelligence. Algorithms analyze sensor data to predict possible failures weeks or even months before they occur. It's like the transformer saying, "Hey, I need an overhaul."
That's fascinating. I imagine, then, that there are a lot of sensors today that allow you to adapt older installations to monitor them with artificial intelligence, right?
Exactly. It all depends on the roadmap they want to implement for maintenance.
But there are three main approaches to maintenance: preventive, predictive, and corrective. Let's start with preventive maintenance. What are they?
It's like taking your car to the shop for regular checkups. We perform regular inspections to detect and correct problems before they cause failures.
And predictive, what makes it different?
Predictive maintenance is based on constant monitoring. Sensors detect patterns that indicate wear or malfunction, allowing action only when necessary. It is an early warning system.
What about corrective maintenance?
Corrective maintenance is carried out after a breakdown. It is the least advisable because it involves costly repairs and possible service interruptions, with the consequent cost to production. Therefore, preventive and predictive maintenance should be prioritized.
Good maintenance doesn't just prevent failures, does it?
Exactly. It also reduces energy losses, reducing consumption and carbon emissions. For example, a predictive maintenance model on railway transformers saved 178,311 kilowatt-hours per year.
That is equivalent to a significant consumption of several homes. It is a great contribution to sustainability.
Now let's talk about the future. What promising innovations do you see on the horizon?
Three areas stand out: robotics, robots for inspections and repairs in hazardous environments; nanotechnology, new materials for more efficient and durable transformers; Internet of Things, IoT-connected smart sensors that allow continuous monitoring of the entire network.
It's like having a digital nervous system that optimizes maintenance and guarantees uninterrupted supply, isn't it?
Exactly. These technologies are transforming and will transform our electric grid into a smarter, more sustainable system.
We have explored how predictive monitoring and new technologies are revolutionizing transformer maintenance.
It is an exciting field that combines engineering, innovation, and sustainability.
And a future full of opportunities for those who wish to contribute to a more efficient and cleaner electricity system.
We hope you found this information useful. If you have any doubts or questions, just contact Antonio Fresco Navacerrada on LinkedIn. Thanks for joining us. See you in the next video.